Chapter 9, third video. Today I am discussing about 9.3 uses algorithmic approach to solve problems. The content is about algorithms, flowcharts, pseudocodes, and hand traces. The outcomes expected briefly describes the algorithms, identify the standard symbols used to draw flowcharts, draws flowchart to illustrate solutions to a given problem, write pseudocode to illustrate solutions to a given problem, uses hand traces to verify the solutions. So let's go to the lesson. What is an algorithm? Algorithm is process or set of rules to follow in calculations or other problem solving operations by a computer. In essence, algorithms are simply a series of instructions that are followed step by step to do something useful or solve a problem. Then, collection of actions for procedure. The intention is to solve some problem. Then there are three parts: input, process, and output in algorithm. Input, then the process is set of rules to obtain the expected outcome from a given input. Then the output is get. So, pros or advantages using the algorithm. It is a step-by representation of solutions to a given problem, which makes it easy to understand. Every step in an algorithm has its own logical sequence, so it is easy to debug. By using an algorithm, the problem is broken down into smaller pieces or steps. Hence, it is easier for a programmer to convert it into an actual program. An algorithm acts as a blueprint of a program and helps during program development. In addition to, an algorithm uses definite procedure. It is easy to first develop an algorithm and then convert it into a flowchart and then into a computer program. This is the process we are developing in programming languages using. We got the identify the problem. We go through the stepwise problem solving. Then we develop the algorithm. Then the algorithm move for flowchart, linear actions. Then write down that program using the programming language. It is not dependent on any programming language, so it is easy to understand for anyone, even without programming knowledge. Then the algorithm and also a flowchart is targeting non-technical people. It is independent from programming languages, therefore any person can convert that algorithm, send it the flowchart, then for a separate different kind of programming languages it can be implemented. So there are some few disadvantages when we consider algorithms. It can be introduced as a limitation also. Algorithms are time consuming. Big tasks are difficult to put in algorithms. Another one is difficult to show branching and looping in algorithms. Understanding complex logic through algorithms can be very difficult. Yeah. Let's move to the representing an algorithm. Then we identify what is meant by algorithm, input and decisions and output, the advantages and disadvantages. It is non-technical people can identify. Then first one, develop the algorithm, then go to the flowchart and implement by using a programming language. Now we are going to represent the algorithm. There are two main ways that algorithm can be represented: pseudocode and flowcharts. Flowchart is a diagrammatic representation of sequence of logical step of a program. Flowcharts use simple geometric shapes to depict processes and arrows to show relationship and processes data flow. Guidelines for developing flowcharts. Flowcharts can have only one start and one stop symbol, but there is a limitation. We can have many endpoints, but only one starting point. It has been checked in A-level examination, given some 2 endpoints. Therefore, the theory should be changed. Flowcharts can only have one starting point, but can have multiple endpoints. One-page connectors are referenced using numbers. Off-page connectors are referenced using the alphabets. General flow of processors is top to bottom or left to right. Arrows should not cross each other. So these are the symbols that using for drawing the flowcharts. Generally, it is good for drawing flowcharts for non-linear thinkers. If you are linear thinker person who thinks in terms of step-by-step progressions, a flowchart may work better for your problem-solving strategy. A flowchart is a graphical representation of workflow or process with various shapes connected by arrows representing each other. So, this is the start and stop symbol. You start at the beginning and end of the algorithm to show start and end of the program process. Indicate processes like mathematical operations. Input/output that can be denoted as input and also output. Use start for denoting program inputs and output. This is a decision. Decision stands for decision statements in a program where answer is usually yes or no. Arrow shows relationships between different shapes. On-page connector and off-page connector connects 2 or more parts of flowchart which are on the same page. On-page connector use. Off-page connectors are spread over different pages. You know, the computer system has input, process, and output. The input and the process, we can separate it. Input, same symbol, process, then this is the symbol, then output, this is the same symbol. Then we can left to right, left symbol as the start point symbol and the right one for the end symbol. Then in the intermediate is the process. In the process, we use decisions for and arrows for the combinations with other components. An algorithm may include 1 or more control structure out of 3. 3 types of control structures are shown below. Before I will explain, to start your problem solving flowchart, follow these steps. Draw a starting shape to state your problem. Then second one, draw a decision shape where you can ask questions that will give you yes or no answers. Based on the yes or no answers, draw arrows connecting the possible paths you can take to work through the steps and individual processes. Fourth one is continue following paths and asking questions until you reach a logical solution to the stated problem. Try the solution. If it works, you are done. If it doesn't work, review the flowchart to analyze what may have gone wrong and rework the flowchart until you find the solution that works. This is the process of drawing a flowchart. In the previous discussions, we have identified problem solving steps. Likewise, now we know the problem and the solution design. Then it is a representation of actions, how to solve the problem. There are 3 approaches: sequence, selection, and repetitions. This is a graphical representation of the step sequence linearly. It is go through start point to end point. In selection, there is a decision, and repetition also there is a decision. In sequence, there is interdependency. decision. So in selection, in the input output processes, intermediately we check some condition. With the condition, it can be two flows, yes and no. So two flows for the process. The repetition also repeated the actions, but there is a condition. When the condition getting through, it can be true for the end stage. These are linearly go top to down. This is also top to down, but repetition we go bottom to up to some level through some condition. Then when condition is satisfied, we go for the end stage. So sequence. I explain more about these three approaches. First one is sequence, execution of instructions in an algorithm sequentially from top to the bottom is called sequence. Let's see how it is represented in a flowchart. Cover in a textbook. Let's represent cover in a textbook in a flowchart. This is the linear action, top to bottom. There are processes, no input output, two symbols for demonstrate start and stop status. First one, cut the paper required to cover the textbook in a suitable size. Place the textbook on the paper. Then when it is completed, we go to the next action. The next action is fold the outer cover inward. Then go to the next action. Paste the inside close to the edge of the outer cover. Then go to the next step, next process, next task. Label your textbook in front for identification. Then it is completed. Then it is represented as the stop state. Yeah. Another example, finding the area and perimeter of rectangle. These are very simple examples. It will be beneficial to understand the theory behind the flowchart and symbols and flow. First one is start symbol. Getting inputs, there is a process symbol and output symbol and the end stage. First one, get the length and width as the input. Then the process is going to calculate area and perimeter. Logically, length multiplied by width and perimeter calculate length plus width multiplied by 2. Then calculations are displayed as the output, display the area and perimeter. Then the process is end. Then the next one is selection. The selection is there is a condition. Then when the satisfied, there is a new flow and not state is then it is not satisfied. There is a separate another flow. Here it is expected to make making decisions on which step to follow depending on the condition given by the algorithm. In a selection, the condition is checked first and the flow direction is chosen based on whether the condition is true or false. For example, let's consider an instance where a ceiling fan is operated. When the switch is on, the ceiling fan operates if there is power. If there is no power, the ceiling fan does not operate. The representation of the graphically, the flowchart notations, start, the start symbol. There are few processors, there isn't any input, there isn't the output. So these are processors. Switch on, there is a condition, there is a case is checking, is power is available. Not it getting the not condition, fan is not functioning, then it is power is available, yours, then fan is functioning. Accordingly, if power is available, the fan will function. If power is not available, the fan will not function. Yes, we know some situations we are getting hungry, we getting thirsty, we repeatedly drink, we repeatedly eat something when until we getting satisfied, until we getting some state of satisfied state. That's a repeating actions. So there are many repeating actions we are doing in day-to-day life. Assume we are ready for normal days in weekday and weekends. If it is a weekend or if it is going to a tuition class, the today morning process, the wearings will be changed depending on the day and or location or event. There is a condition with that also. Third one is repetition. Execution of an instructions or several instructions in an algorithm repeatedly until the condition is satisfied is called repetition. A repetition will take place depending on whether a condition is satisfied or not satisfied. For example, natural water cycle is process that takes place repeatedly. As an example, do you know that since your childhood you used to save money by using till to put money? The one who is used to save money in a till will always put money again and again repeatedly until the till fills. So here the process of putting money is repeated until the condition that is till becomes fully satisfied. One of the examples, repetitions. There are many examples in our day-to-day life we are doing repeatedly until some condition is get satisfied. We are training, we are learning sometimes repeatedly to get some satisfied stated. First one is example, start, take a till to put money as the process. There are two processes. Then there is a condition is still full. It is not full. Then again put the money. When the till is full, the process is stopped. The simple action, simple scenario, but you should identify scenario wise and repetitions, the process with the input and output. There are two processes and the stop state. Checking of conditions for repetitions can take place in two ways. Check the condition before repetition start, check the condition after functioning ends. So in our programming languages, in upcoming lessons, we learn these two conditions, how it is implemented using programming language. Then as academically we use Python language for identify and I learn these factors. Checking whether ink is available before writing start, take a pen. Is ink available is a condition. Then it is yes, write repeatedly. The ink is not available, condition is getting the result as no, then the process finished. Act of writing until ink finishes takes place again and again repeatedly. Then the right side flowchart demonstrate the start, take pen, the process, write process. There's a condition is ink finished, then not finished, repeatedly doing the right action. Then ink is finished, we go to the stop state. So you can identify that condition is, then here is first action before the process, it is checking the conditions. Then here it is checking after the action is done. Pseudocode. We identify it and go through flowchart, get the example wise and the knowledge behind the flowchart. The second representation, the algorithm is pseudocode. Most programs are developed using programming languages. These languages have specific syntax that must be used so that the program will run properly. Pseudocode is not a programming language. It is a simple way of describing a set of instructions that does not have to use specific syntax. Writing in pseudocode is similar to writing in a programming language. Each step of the algorithm is written on line of its own in sequence. Usually instructions are written in uppercase variables in lowercase and messages in sentence case. When an algorithm is presented in simple English terms, it is called a pseudocode. Pseudocode are independent of a computer language. It is very important things you should identify. Pseudocode is not dependent on the programming languages. Pseudocodes can be converted to any programming language instructions. Hence, pseudocodes make computer programming easier. In pseudocode, input asks questions, output prints a message on the screen. So, pseudocode is representation of an algorithm. It has some identified symbols we can use to more explain about the algorithm. Begin to indicate an begin, end to indicate an end, input, read, get are commonly used to indicate an input, output, display, so are used to show an output. One of the word we can use to show an output. Input, read, get can be used to one of the word from this to indicate an input. Process, calculate to indicate a process. If then else end if used to indicate a selection. In algorithm, we identify that if condition selection. We can use if then else end if like those words, one of those words or a few of them to demonstrate represent indicate a selection. For do, while, end, while, repeat until some of the repetitions to use to indicate in pseudocode. Let's go through example. Example 1, finding area of a circle. First one, we mentioned begin is word to represent indicate that the pseudocode, the program is going to begin. Then next one is input, radius, get as a variable. The next one is process, calculate, meaning as a process, area equal 2 to 22 divided by 7 multiplied by radius multiplied by radius. Then next one is output, the keyword use display for to represent the variable area as output. Then the process is end. Yeah. Then let's go to another example, finding whether the number is odd or even. There is a selection here. In second example, begin the pseudocode, then read number as n as a variable, we get the number. Then the process is going calculate remainder after number is divided by 2. If remainder equals 0, then go to the statement, display even number. If we not satisfied, go to the else condition, display odd number, then in the if condition. And with that, we totally end the process. That means end state. So there is input, read input, then this is the process, and these are the outputs. We should identify what are the inputs, what is the process, and what are the outputs. Another example, a simple program could be created to ask someone their name and age and to make a comment based on this. This program represented pseudocode would like this. Then output, get the what is your name from user, get the input as a, then get the input, user input their name. It is the third that third one, store user's input in the name variable, then output hello plus the name variable given by the user, output how old are you, get the input from the user input their age, store the user's input in the age variable. Then there is a if condition, that's the selection. Then condition is age greater than or equal 70. Then the condition is going to then and else output your age perfection. Then the output's going to the else condition, spring children, spring chicken. Then we discuss the objective 3. Then we have done more parts, flowchart and pseudocode. In my next video, I am going to discuss last 10 years, pseudocode, flowchart, MCQ answers with questions as a discussion. Let's meet in video number 4. Thank you.